I hope everyone is able to see the screen and my voice is also audible. Okay, thank you. We'll just start in a minute. Hello, good evening everyone. Welcome to the NPTEL online course on wastewater treatment and recycling. So today we'll be discussing the questions and problems related to the contents of week 2. So just to remind you, as you all know, the course instructor is Professor Manoj Kumar Tiwari from IIT Kharagpur, and I am one of the teaching assistant. My name is Akash Saha, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. So I hope you have gone through the lectures of week 2. So in week 2, we discussed majorly about the wastewater generation and quantity estimation. So why do we need to quantify the amount of sewage that is generated in a society or in a municipality? And what is the concept of dry weather flow, and what are separate and combined sewage? And then in the quantity estimation, what are the input components, what are the different steps, and related to that, how do we choose the design period and do the estimation of design population. So we have different methods of design to forecast the population, like the arithmetic, geometric, okay, incremental increase. So just a minute. Yeah, incremental increase, master plan method, graphical method, and others. So there are proper steps given in the lectures on how to do each of them. We will revise that once again. And then the uh, quantity estimation related to the peak flow estimation and the additional inflows that are coming into the sewer. Okay, so this was the basic overview of whatever we have discussed. So now we'll solve some multiple choice questions, and in that also some numericals will be there. So in this week also we won't have any difficult numericals. Okay, mostly related to population forecasting and the sewage quantity estimation, and slowly in the subsequent classes we will have more. Okay, so let us start with the first problem. So it says that dry weather flow is the actual flow of sanitary sewage, the stormwater contribution to sewers in dry season, combined stormwater flow plus sanitary sewage flow, quantity of sanitary sewage flow subtracted from stormwater flow. So what do we call it as? Dry weather flow. So please type in the correct options in the chat box. So I request whatever answer you feel is correct, please put it in the chat box. And also in the last class, those who have not filled the Google Sheet, please access the link that I have already pinned in the chat box. Okay, just your name and email ID. That is enough. Okay, please start giving the answers. So it is asking about dry weather flow. Almost 10 people are there, so I request everyone to participate in answering so that we can discuss. Okay. So generally we will have two types of line. One will be carrying the sewage, another will be the storm water. So as they are saying dry weather flow, okay, so mostly we mean that the sewage will be taken into consideration. So the actual flow of sanitary sewage is the dry weather flow. So most of you have answered this correctly. The actual flow of sanitary sewage, okay. Uh, so basically it happens during the dry seasons, because in wet seasons we will also have the storm water flow. So depends on what kind of sewerage system you are designing, whether it's a separate sewage system or individual. So in sorry, separate or combined. Okay, so dry weather flow means the actual flow of sanitary sewage which is occurring in the dry seasons, right? I hope this is clear. We will move forward. The quantity of municipal wastewater generated from a city depends on population of the city, water consumption pattern of the inhabitants, both or neither of them. Both or neither of them. The quantity of municipal wastewater generated. Okay, so I think most of you are answered it correctly. It is both the population and the water consumption pattern. So can someone tell me roughly how much of the water that we consume turns into sewage? What is the percentage? Can someone type it in the chat box or tell me what is the general range of the conversion of water into sewage? No idea? If I am getting 100 liters of water supplied to me, so how many liters of sewage generally we consider to be converted into sewage? How much? Any idea? Because these things we will use in the calculation. So that's why I'm asking you. 80. Yeah, so 80 is a good estimate. 100 liter according to what mass balance you are trying to tell? No, I'm saying that, can you please clarify what are you indicating to by mass balance here? Anyway, but the answer is around 80 to 85% we generally think will convert into the sewage. Okay, so that is a good estimate. You will see some problems related to that, so don't worry. So municipal wastewater quantity generated is typically based on the number of inhabitants, that is the population, and their water use practices. Okay, so I hope this is clear. If you have any doubt, you can ask me. So let me discuss one more thing. So when we are talking about water consumption pattern, so on what factors do you think the water demand changes? Can someone tell me? On what factor do you think the water demand changes? What are the different factors of a city or whatever? So I am talking about not about wastewater here. I am talking about water demand. So first, water has to be supplied to the households, right? So on what factor the amount of water or the water demand cha- changes? What are the various factors?
Based on the people requirements, means how many depending upon the population.
No, population won't. I am asking about water demand. So when I say demand, it is the amount of water required per person. So population will control the total quantity of water
Total
required.
quantity.
Yes, but
Mm-hmm.
here I am asking about the water demand, or let's say the amount of water required per person. So
Basically, maybe based on the season wise, also it will vary
yes,
because of season
season will change the demand. Definitely season is
demand.
one of the reason. What else? Season is one of the major reason. Then the type of sewerage system is also important, because if we have a fully flushing system, the amount of water requirement will be more, because in cities we have a full flushing system. Okay, so the amount of water is right. Size of the city is also correct. Climatic condition is right. Yes. Habits or the lifestyle of the people. Yeah, absolutely correct. System of supply. Mm, okay, so this is somewhat tricky. System or the cost of water. Do you think if the cost or the system of supply changes, will the water demand change? If the cost of water is more, do you think the amount required for a person will change? Yeah, maybe he will consume it more or less based on the price, but the requirement will still be the same. So we should not say that system of supply or cost of water or type of distribution or pressure of distribution. These things generally people tend to believe falls under the factors affecting water demand. But no, these won't affect the water demand, because the amount of water requirement will still be the same. Yes, you have any question? You can unmute and ask. If you have any queries, you can unmute and ask. Okay. So I was saying that, so when we say water demand, okay, if I want to know what are the factors that contribute to my water demand, so one will be type of sewerage system, because depending whether it's a full flushing or not, the amount of water required will be more or less. Then the type of lifestyle. Okay, in city the lifestyle is different, so demand will be more. Then the climatic conditions. In hot climate we need more water. Okay, we can say type of lifestyle or habits, both are the same. Okay, then what else? Then extent of industrialization.
Separate the combined.
Sorry. So extent of industrialization, that also depends, that's also factors the amount of water required. But if we say cost of water, if we say quality of water, okay, if we say type of distribution, okay, if we say the pressure in the distribution, so these things will not change the demand will still the same, only the consumption will vary. Consumption varies. Okay, so we have to be very careful based on, because in some books or some places they mark these thing also a factor for what change in water demand, but that should not be the case. I hope you are able to realize that. Okay, if you still have any doubt we can discuss. Okay, so this is something that I wanted to tell. Okay, so we'll move next. Identify the correct statements regarding the design capacity of sewer systems. Statement 1. Incorrect estimation of quantity of sewage generated may lead to inadequate or hydraulically inefficient sewer system design. Statement 2. Underestimation of design sewage flow will make the system uneconomical. So which of the option is correct? Please put your answers in the chat box. C. Okay. C. Any other answer? I request others also to please participate in answering the question. Okay, so many of you are answering it as C. One of them is A. Okay. So I would request everyone to please read the statement 2 carefully. Please read the statement 2 carefully, and then again, if you want to answer, please answer. Okay, so now I think
So both under and over also may lead to uneconomical and inadequate capacity.
so my question is, if it is underestimated design sewage flow, okay, suppose let's say the requirement is of 20 million liters per day, but I design my system for only 10 million liters per day. I am underestimating the design sewage flow. Will it make my system uneconomical? If I estimate it to be, instead of 20, if I estimate it to be 30, okay, overestimation, then definitely it will make it uneconomical. But if I underestimate the design sewage flow, it will not make my system uneconomical, right? It will make my system like in cost effective way, okay, but it would not be able to carry the load. So that is the problem. So statement 2 is incorrect, while statement 1 is definitely correct, because I think statement 1, no one thinks that it is incorrect. So statement 2, you have to be careful, because underestimation of divine sewage flow will make my system not uneconomical, but rather economical. Okay. So the same thing is has been written here. So please be careful with the words, right? Moving to the next problem, I hope that is clear to all of you. Design period of various sewerage components are usually based on availability of funds for design, useful life of specific components, the duration of sewerage services required, and average life of sewerage facility. So what do you think is correct? Design period of various sewerage components. Okay, yes. So most of you are answered it correctly. It is the useful life of the specific components. Okay, because after the useful life, the required purpose of the component will not be served. Okay, so that's why different components have different design periods based on how, like till what time they can serve the purpose, right? So we have like pumps or mains or transmission lines. So each of them has some different lifetime. So we have one question there. So there we'll discuss in detail, like what are the useful life of each of the components. Okay, it will come in the subsequent problem. Next, which of these population forecasting method is likely to overestimate the forecasted population for a city of moderate size and age? Arithmetic increase, incremental increase, geometric increase, or logistic growth method? Which method is likely to overestimate the forecasted population? I request others also to please answer. Okay, so yeah, most of you are answering it correctly. It is the geometric increase method. Okay, so incremental, generally for a moderate size city, okay, we generally use the incremental increase method to get a appropriate forecast. But if you do the geometric increase method, it will tend to overestimate the population. Okay, we have some problems also. So for the same data we will do for arithmetic, incremental, and geometric, we will find that for geometric the estimation is always higher than the other two, right? Next, using growth composition analysis method, that is the demographic method, population is estimated based on annual birth rate, death rate, and migration rates. Which of these is relatively the most difficult to estimate? So this is pretty direct. Which of these is relatively the most difficult to estimate? Birth, death, migration, or all the above? I think it's a very logical and general knowledge based answer. So there is no point of discussing it much. So it will be definitely the migration rate, because the estimation of how much migration is very difficult depending on the development, the job opportunities, the economic or the social factors. Okay, so migration rate. The peak factor is used to estimate peak for sewer designs. The correct relation between the peak factor of sewage flow estimation with the increase in population is: peak factors have large fluctuation for highly populated cities. Peak factor is independent of population increase. Peak factor is Peak factor typically increased with the increase in population. Peak factor typically decreases with the increase in population. Which of them is correct? So here we are comparing the peak factor with the population. So how do the do they vary? Is there any direct relation, or there is no relation, or whether one will increase and one will decrease? I hope you are aware of what is peak factor. So what is peak factor? Can someone tell me the ratio? What is the peak factor ratio? What is the peak factor ratio? No, I am not asking you the value. I am asking, like, what are the two components of peak factor? What are the two components? So peak factor is nothing but the peak flow by the average flow, right? peak flow by the average flow. So yeah, what do you think is the relation between the peak flow and the population? So I'm getting mixed answers. You are basically confused between C and D. So let's think in a way that suppose in a place there are only two people living and in a place there are 100 people living. So where do you think the difference between the maximum and the average will be more? Whether it will be for less number of people or more number of people. Okay. So think in that way. So then you will be able to give the correct answer. So whenever the population increases, the difference between the peak and the average decreases. So that's why we say the peak factor decreases, because the it averages out with the more population. Okay, but if we have very less number of people, the difference between the maximum usage and the average usage will be higher, because the number of sample points are very less. But if we have for a city of more than 1 lakh, or let's say 2 lakhs, okay, or whatever, then the difference between the peak demand and the average demand will come more and more closer. So that's why the peak factor decreases. So the correct answer is option D. Okay. So this thing you have to be. So if you remember, so we have a general thumb rule that for population versus peak factor. So the population is more than 50,000, then peak factor is 3. If it is 50,000 to, let's say, 2 lakh, it is 2.5. And if it is, sorry, it should be less than 50,000. Okay. And if it is more than 2 lakhs, then it is 2. Okay. So generally, we take the peak factor as the weighted average of all three, weighted average, which turns out to be around 2.7. So mostly we take the peak factor as around 2.7. Okay. Okay, I hope this is clear to all of you. Moving forward, population forecast in logistic growth model is limited by the availability of the master plan, exponential growth rate, migration rate, or the population carrying capacity of the region. So logistic growth model is limited by which of them? Which of them? C, D. Okay. Any other answer? C, D. So do you know what the logistic growth model curve is also called as? What is the other name of logistic growth model curve? If you know the shape, then you will be able to Guess the answer. What is the shape of?
Yes.
Sorry?
Yes, chef.
S
Yes.
shape. Yes. Yes. So for logistic growth model, so let's say we have time and population here. So it is somewhat like S shape. Okay, S shape. So after a certain point, it attains a saturation. It cannot go beyond this point. Okay, beyond this point. The population, this population will be kind of constant. Okay, the growth rate will become zero. So this is the population carrying capacity of the system. So beyond this point, it cannot grow. Okay, so we have developed several formulas for this also. So the correct answer is option D. The population carrying capacity of the region is the limiting factor of the logistic growth model. Okay, in other methods, you will see with time the population will keep on increasing, be it arithmetic increase, geometric increase, or whatever. But if we say that a particular city or place is following the logistic growth model, then beyond a certain point, there is no increase in population. It will reach a saturation point. Okay, so that's why we call it as a S curve model. The growth rate nearly becomes zero, right? Moving forward. As per CPHEEO Manual 2012, the conventional sewers shall be designed for a minimum sewage flow of 30 liters per day per person, 55, 100 or 250. So yes, mostly it is 100 liters per capita per day. So can someone tell me from where this number is coming? So from where this number 100 is coming? What is the logic behind this? How can you remember? What is the logic behind this? What is the logic behind the number 100 liters per capita per day? Please think. No answer?
Water supply rate depends on its
Yes. Yes. So what is the water supply rate?
sir 135 LPCD.
135 LPCD. Yes. So 135 LPCD, if we take around 75 to 80% of that, we consider it will convert into sewage. So roughly 75 to 80% is around 100 liters per day. So that's why this value is 100 liters per capita per day, because the water supply norm is 135 liter per capita per day. Okay, so that's how it is connected. So now I think it will be, because 135 LPCD is a very common number. We always use this. Which of these may lead to additional inflow to sewer lines? Water used from unaccounted private water supplies, water used for gardening and horticulture, water losses from losses from water supply systems, or all of the above. Which of them will lead to additional inflow to sewer lines?
C.
Okay. So one thing is that the inflow that we expect in a sewer line is nothing but the converted sewage from the water supply line. Okay, so how much water supply we are getting, okay, that will be converted to sewage and then will be flowing into the sewer line. So definitely we will account that thing in our design of the sewer lines. But how can we get additional inflow? So additional inflow from can be from the private water supplies, which we have not accounted in our design. Okay, so rather than the government supply, if we have a unaccounted water supply system from any other source, so those things also will go through our household and end up in the sewer lines, right? So that will only lead to the additional inflow. Whereas the water used in gardening or horticulture or the losses from water supply system will decrease my inflow to the sewer line, not increase. Okay, those will not come into my sewer lines because anyway it is used in somewhere else. So the correct answer is option A. That is the water used from unaccounted private water supplies. Okay, suppose some people are getting some water tank, a separate water tank for their daily requirement. Then that thing also will directly go into the sewer line, which is unaccounted in our design. So that is the right answer. Okay. Now a small numerical. The population of a city was recorded as 2.5, 3.2, and 4.1 and 5.2 lakhs in 1991, 2001, 2011, and 2021 respectively. Based on the data, answer the following. The forecasted population in 2041 using arithmetic increase method. Okay, and you have to tell the answer in lakhs. Okay, so please try to solve this. I'll wait for 2 minutes and then I will give you the solution. Please try it out. I'll wait for some time.
So answer is 4.4 lakh.
4.4. How it will decrease? Because 2.5 to 3.2, then 4.1, then 5.2. You are saying that 4.4. How the population forecast will decrease in 2041? Please check the answer again. So we'll do this method with arithmetic increase, geometric increase, and incremental increase. All the three methods we will use. So if you have solved one, you can move on to the next also. But if you get the answer, you let me know. So what is the first thing that we need to calculate?
So first need to calculate arithmetic, that is increase population.
Yeah, what is the increase? Average increase, decadal average increase. Decadal average increase.
Next one is sum of that.
Sum. No, Okay. Let me give you
It
the
is 7 lakhs. It is 7 lakhs, sir.
7 lakhs. Yeah, 7 is the right answer. So let's see how is it 7 lakhs. So generally we do this by making a table. You can do this without also the table. So year, then population, and then increase. So these are the three things we have to note, make a note of. So population is 2.5, 3.2, 4.1, and 5.2. So for each decade, we will see the increase. So from 1991 to 2001, the increase is 3.2 minus 2.5, that is 0.7. Similarly, from 3.2 to 4.1, the increase is 0.9. Then from this to this, the increase is 1.1. Okay, then we will find the average. Average of zero point 0.7 plus zero point 0.9 plus 1.1 by 3, because there are three values, so by 3, so average will come out to be 0.9. Okay, so now the population at 2041 will be the population of the last decade, that is 2021, plus the number of decades into the average, okay, so that is 5.2 plus number of decades. So 2021 to 2041, number of decade will be 2 into the average, so that is equal to 7 lakhs. Okay, so that's how we have to do it. First we have to calculate the individual increase, take the average of the individual increase, and then multiply it with the number of decades from where we are counting. Okay, if they would have asked for 2071, then n would be equal to 5. So like that we have to take. I hope this is clear to all of you. Now let us try solving by geometric. So have anyone got the answer for geometric increase? Do you have the answer for geometric increase? So let me solve this. So for geometric increase, for the same value, you have to find out the percentage increase. Percentage increase, right? So how will we find the percentage increase? So for 2020, for 2001, the percentage increase is 0.7 by the population of the last decade, that is 2.5. So it will 0.28. Then 0.9 divided by 3.2, it will be 0.28125. Then 1.1 divided by 4.1, it will be 0.268. Okay, then we have to take the geometric mean of it. Geometric mean of it. So what is the geometric mean of these three things? That is equal to cube root of 0.28 into 0.28125 into 0.268. Okay, cube root of the multiplication of all these three values. So this will be equal to 0.267. Okay, so here since there are three values, we have taken the cube root. If there are two values, we will take the square root. So like that, nth root we have to take. So the number of points, that nth root we have to take. If there are five values, then what we will do? We will multiply those five values and take the 1 by 5th power of it. Okay, or we can say for n values, we will take the 1 by n power of that. We will multiply those n values and take the 1 by nth power of that. Okay, so now once we got the geometric mean, what we will do? So for 2041 by geometric increase method, the answer will be population at the last known decade into 1 plus the geometric mean. We call it as R. Okay, geometric mean R to the power of the number of decades we have to find out. So here it is N or 2. So the answer will be 8.47 lakhs. Is there any doubt in this? I hope this is clear. Any doubt with the calculation, please let me know. Okay. I hope this is clear. Now the last one. The last one is the incremental increase method. So I'm just rubbing this. Okay. So can someone tell me the answer for the incremental increase method? So I request everyone to please have a calculator and a notepad with you when you are coming for the classes from now on. Okay, because that is the most essential thing required. Without a calculator, and maybe this class is okay, but from next class we will definitely need. This class also we need, sure. So for incremental increase method, we will find something called as incremental increase. Okay, so in the arithmetic mean method, we found out what is the increase in each decade. Okay, then in incremental increase, we will find the incremental increase in the decades. Okay, so this will be nothing but 0.9 minus 0.7, so 0.2. This will be 1.1 minus 0.9, that is again 0.2. So we have to take the average of it. So this is 0.2 plus 0.2 by 2, that is 0.2. So this is the incremental increase. Okay, we will call it as I, incremental increase. Okay, now this incremental increase can be positive, can be negative. Okay, because in some places the increase can be positive, can be negative, whatever. So we have to take everything into account and find the average. So simple thing. So for population at 2041 by incremental increase method will be plus n times of average plus I into I plus 1, or I will not I into I plus 1, that will be n into n plus 1 by 2 into I. Okay, n into n plus 1 by 2 into I. So this will be 5.2 plus 2.2 into 0.9. So this is same as the arithmetic increase method, plus 2 into 2 plus 1 by 2 into 0.2. 7.6 lakhs. Okay, so from here you can say that by arithmetic method we get the value as 7 lakhs. By incremental increase method we get the value as 7.6 lakhs for the same data. Okay, and for the geometric increase method we got the value as 8.47 lakhs. So we can see there is an increase in the estimation. Okay, for the same set of data, the amount of population that is coming out in the end changes. Okay, so that's why geometric mean method always overestimates, and arithmetic gives the least answer. Okay, I hope this is fine for all of you. We will move to the next problem. Okay, so all the answers are given, so I'm just skipping it. Next, a city with 12 lakh population receive 150 LPCD water supply. Assuming that 80% of the water is used is received as municipal sewage, the maximum daily flow of sewage from the city, assuming a peak daily factor of 2 would be. So we have to find out the maximum daily flow of sewage in MLD. So please give me the answer. What will be the maximum daily flow of sewage from the city? What is the maximum daily flow of sewage from the city? B. So B is 288. Yeah, that is the correct answer. B is the correct answer. So quickly, it's very simple, I know. So let's see how to solve this. So we have 150 LPCD, right? So 150 liters per capita per day. So what will be my average daily water supply? So average daily water supply will be 150 LPCD into the population, that is 12 lakhs. Okay, so this will come out to be 180 into 10 to the power 6 liter per day. So that is equal to 180 mld. We call it as 180 mld. Now, average daily sewage flow. So average daily sewage flow will be 80% of that. So 80 by 100 into 180 mld. That is 144 mld. So then maximum daily sewage flow. That is, so that factor is given as 2 into 144. So 288 mld. Okay, right? I hope this is clear to all of you. Next, the average. So please stop me if I am going too fast since the problems are very simple. So I may be going a little fast. So if in case you are not able to understand, please stop me then and there. Okay, you can unmute yourself and ask me the solution once again. I'll be happy to answer. Okay, please stop me. Okay, next problem. The average daily sewage flow from city is 16 mld. Assuming daily and hourly peak factor as 2 and 1.5 respectively, the maximum peak hourly flow of the sewage would be. So you have to find out the maximum peak hourly flow. Maximum hourly flow or peak hourly flow. Any answer? So also please take care of the unit. It is in meter cube per hour. That's why it's called peak hourly flow. D. Yes, D is the right answer. 2000 meter cube per hour. It is the right answer. Okay, so let's see the solution. So my average daily flow is 16 mld, right? So my maximum daily flow would be 16 into the factor 2. So that is 32 mld. Now average hourly flow on a maximum day. So my maximum flow is 32. So on a maximum day, what will be my average flow? So that will be 32 mld. So instead of ml, I am writing as 10 to the power 3 meter cube. So this is same as million liters. Okay, divided by 24 hours. So day I am writing it as 24 hours. So this would be 1333.33 meter cube per hour. Okay, we have to change in per hour. Then the peak hourly flow will be nothing but the peak factor 1.5 for hourly into 133.33. 1333.33. So that is 2000. Okay, I hope this is fine. Any doubt in this? Any doubt in this? So you can make note of this formula. This will be little helpful. So generally what we have is something called as a Goodrich equation. Okay, so it is a factor which is the ratio of maximum demand by average demand. Okay, and this is equal to 180 into t to the power 0.1. 0.1. But we have to be very careful here. T is time in days. Okay, and t should be greater or equal to 1. Minimum for one day you have to find out. Okay, so that is the thing. So if you just make a graph like demand versus fluctuation, or make a table. So for daily, so that is t equal to 1, we will get the answer as 1.8. Fluctuation or the value of p will be 1.8. If we do weekly for 7, it will be 1.48. For monthly, it will be 1.28. And for yearly, it will be close to 1. So here is t is equal to 1, t is equal to 7, t is equal to 30, like that. So you can see as the time or the sample size is increasing, the fluctuation decreases. So that's what we also talked about, the fluctuation of peak factor with respect to population. As the population increases, the fluctuation or the peak factor decreases. So similarly, as here also the time is increasing, the fluctuation is decreasing. And for hourly, we cannot calculate from Goodrick equation, but generally it is from observation, it has been found to be 2.7. This is from observation. Okay, here we cannot apply the Goodrick formula. Okay, we cannot do that. Right, for the other thing, we can use this formula. So that's why you can see the factors. Okay, so this is something extra. Right, we'll move forward. Were you aware of this Gutrick equation? Were you aware of this? Anyone? Yes, no, no. Okay. Okay, I hope this would help you just to understand, because in your questions and all, this factor of 2, 1.5, this will directly be given, but you should know from where these factors are coming. What are the what is the backing behind this? Okay, so this is basically an empirical formula observed from various trends. Okay, so and how these factors are behaving with time, that thing you should know. Next, estimation of agricultural runoff depends on type of crop and cropping pattern, irrigation supplies, precipitation, all of the above.
Option D, all of the above.
Yes, this is very direct. I don't think there is much to discuss in that. So D is the correct answer. Okay, another small numerical. If the development plan rules of a city provide the following reservations for different land uses, that is road 15%, garden 10%, schools 5%, market 5%, calculate the population density per hectare for the plan, use FSI of zero point 0.5 and floor area 10 meter square per person. So you have to find out the population density per hectare. Per hectare. Okay. So FSI is the floor space index, or it is also called as FAR in some places. That is the floor area ratio. So FSI or FAR, whatever you want to say, that is 0.5.
500, no, 250.
No, please check your calculation once again. I hope you are aware in 1 hectare how much meter square are there. What is the conversion?
Option C, 325.
325. Yes, 325. So 1 hectare is 10 to the power 4 meter square, right?
Yes.
Okay, so for others we will see. So for residential development, how much area do we have? So out of 100, 15 went for roads, 10 went for garden, 5 went for schools, and 5 for markets. So we have to subtract all those things. So we have only 65%. Okay, so actual floor area, okay, actual floor area is equal to area for residential into the FSI. So FSI tells you how much floor area you can construct in a given area. Okay, suppose I have a FSI of 2. That means for every 1 meter square of area, I can construct 2 meter square of living area or residential area. Okay, or floor area, whatever. So that 2 meter square can be one above the other or in that one area, whatever way you want to. So for every meter square, how much floor area we can construct is given by FSI. So here my FSI is zero point 0.5. So that means for 1 meter square, I can develop floor for only 0.5 meter square. So that is set by different cities based on their development plans. Okay, so that's how you will do it. So area for residential area will be 65% of, like if I want to do for 1 hectare, that is 10 to the power 4 meters square. Okay, into the FSI, that is 0.5. So this much meter square area I can build as a floor area. So what is the population density? So population density per hectare, or I can say 10,000 meter square, will be equal to 0.65 into 10 to the power 4 into 0.5 divided by the population density that is given as 10 meter square per person. So 10. So this is 325. Okay. I hope this is clear to all of you. Which of the following parameter is not used to quantify the municipal wastewater generated from a city or town? Total population of the city or town, per capita water demand, percentage of utilized water reaching the sewers, or storm water received in the city.
The
Not used.
stormwater. Stormwater
Stormwater,
is
I think
in
this
the
is
city.
very direct. There is nothing to discuss in this. So option D is the right answer here. The population of a planned city needs to be forecasted for a period of 50 years. Which of the following methods will generally result in the lowest design population? Arithmetic, geometric, incremental increase, all will have the same population. What is the answer? We have solved the problem also. So it is definitely the arithmetic increase method because we have already seen that. So there is no point of discussing again. So A. Okay. So I think, yeah. So just take a screenshot of this problem. You can solve and check your answers later. I don't see any point of doing the exercise again. So just take a screenshot and later you can cross verify. Okay, I will go to the other problem. The master plan method of population estimation is based on population density and zone size, annual birth or death rate and migration rates, growth rate characteristics of living being within the limited space and economic constraint, ratio of local to national population in the past few decades.
A. Population density and zone size.
Yes. So that is also pretty direct, population density and zone size for the master plan method of population. Okay. Next. For the design of sewers, estimate of per capita sewage generation is usually based on design population, design period, recommended water use and wastewater generation pattern, wear and tear of the sewers.
C.
C.
So here we are talking about the per capita generation of sewage. So per capita, by per capita I mean per person, how much sewage will be generated will definitely depend not on the population, because we are finding out per person, not on the design period because doesn't depend on how much design period we are focusing on, and does not also depend on the sewer wear and tear. It only depends on how are you going to use the water. Okay, how much you are using it for bathing, how much you are using it for washing, what is your lifestyle and consumption pattern of water. So based on that, the amount of sewage generated per person will depend on. So that's why answer is option C. Arrange the steps of quantity estimation of sewage in correct order. Okay, so estimation of peak flow, estimate the design population, fixing design period, accounting additional inflows. So what is the correct order?
E.
B or C?
C. C.
C.
3214.
3214. So definitely for any estimation, we have to fix up the timeline. Like what is my period of study? Okay, because I want to know at the end of what period is the capacity required. Okay, so first will be fixing the design period. Once we have fixed the design period, we want to know what will be the estimated population, because the based on population only the total quantity will vary. Okay, so we will design the population, then we will find out the peak flow, because once population is designed, we know per capita what is the requirement, how much will be required for the sewage. Okay, and then based on my average flow, I will multiply with the peaking factor, and then I will find out the peak flow. So third is the estimation of peak flow. And once I have estimated the peak flow, I will add what are the additional inflows. Okay, from unaccounted water supplies, or if I am building a combined sewerage system, then what is the amount of storm water that is coming? So additional inflows I will consider. So the correct option is option C, 3214. Okay. So this also we have already seen. Population growth is progressively increasing or decreasing is an assumption under which of the following method of population forecast? Incremental, arithmetic, geometric, growth composition. Population growth is progressively increasing or decreasing. So till now I'm getting mixed answers.
D.
A and
D. Option A, incremental increase method.
okay. So when we were calculating the thing, okay, when we were calculating the this particular problem, we found something called as this incremental increase, right? 1 minute, sorry. So this incremental increase. So this incremental increase per decade can increase or it can decrease. Both can happen. So that we consider in incremental increase method. Okay, so remember this thing. So this incremental increase or decrease can increase or decrease. In one decade it can be 0.2, in another decade it can be 0.1. Okay. Whereas in arithmetic increase, we expect the increase in population will be the same every decade. So A is the right answer. What is the recommended design period for pumping mains as per CPHEO? What is the recommended design period? We discussed something about the useful life. So design period is the useful life of, so for pumping mains.
$15.
Okay. Yes. So most of you answer it as correctly. That is 15 years. So you can see here I have mentioned the design period for, let's say, land acquisition, conventional sewers, non-conventional sewers, pumping mains, pumping stations, civil works, pumping machinery, sewage treatment plants, effluent disposal, effluent utilization. So all these things. Among the following commercial institutions, the expected generation of wastewater per user is highest in which of these? Day schools, colleges, hospital with beds, restaurants, cinema halls. Cinema halls.
Restaurant, hospital, B, hospitals.
Yes. So, so these are very pretty easy questions. So hospital with beds will definitely be the highest. So if you see, so hospital with laundry and beds will take around 340 to 450 liters per bed. While for schools, day schools and colleges, it's only 45 liters. Restaurants it's 70. Cinema halls it's 15. So very less as compared to the hospitals. Determine the approximate quantity of wastewater generated with total daily water consumption as 165 LPCD if the conversion rate is 85% and the total population is 1,65,000. So quickly tell me the answer. I'll not wait for a long time.
165.
Please check your calculation again. How much will the wastewater will be generated? How are you getting 165?
23 MLD.
Yes. So if you see the population is 1,65,000. Yes, you have to find in MLD, million liters per day. Okay. So per capita is 165 LPCD. So total water used. So total water consumption is 165 into 1,65,000. So that is somewhere around 2 crore 72 lakhs 25,000 liters per day. So if you divide by 10 to the power 6, that is million liters. So that would be, and take 85% of that, that will be around 23 MLD because wastewater generated is 85%. So 23 MLD is the right answer. The dry weather flow of a community is usually less than the per capita consumption due to evaporation loss, ground seepage, sewer leakage, none of the above.
D. None of the above.
Okay, others? The dry weather flow of a community is usually less than the per capita consumption due to. So dry weather flow is the amount of actual sewage flow and per capita
Yeah.
consumption. So why there is a difference? Others, please answer. Mr. Rajiv, why did you change your answer? So here Mr. Rajiv only gave the right answer, but then he changed his answer. So the correct answer is A, B, and C, all of them. Okay, because evaporation loss, ground sewage, and sewer leakage, everything will reduce the amount of flow that should come into your sewage. Okay, so storm water adds in the wet weather. Okay, but here we are asking the dry weather flow. So in dry weather flow, evaporation loss can be there. There can be some amount of ground sewage. There can be sewer leakage. So the actual flow that should come into the sewer is lesser, okay, than the per capita consumption. So all option A, B, and C are right. Okay, so again, little tricky question. So I think many people thought that whether A is the answer or B is the answer or C is the answer, and then thought, okay, none of them would be the answer, so let us go with the safer option of none of the above. But that was not the case. A, B, and C, all of them are the right answers. So this generally won't happen in your examination. In your exam, only one of the option will be correct. Okay, so the confusion will be less, but here I have added this type of question. But in exam, only one of the answer will be correct. Or they will tell beforehand whether there are, yeah, that is for my understanding, which one has a double star. Okay, not all questions will have double star. Yeah. Yes. So all A, B, and C are correct. Next, identify the correct statement concerning flow estimation in sewer design. The peak factor of a community typically decreases with increase in the population. The minimum design flow in a sewer may vary from one third to one half of the average flow. The maximum hourly flow is equal to one third of the annual average daily flow on both A and B, which is the correct option. So I think most of you are answered it correctly. Both option A and B are correct. So option D is the right answer. So can someone tell me what would be the correction in option C? How can we correct option C? Yes, the peak factor will decrease with the increase in population. We discussed in the one of the previous problem, right? Because when the population will increase, okay, the fluctuation between the maximum demand and the average demand will decrease. Okay, if more and more people are there, yeah. So what is the option for C? What is the correction in C? Okay, I hope you understood that point of peak factor. So as the population is increasing, the difference between the maximum flow and the average flow will decrease. It will try to average out. Okay. So for option C, the correct answer is generally 3 times or 2.7. So it is 2.73 like that. Okay, so maximum annuity flow is equal to 2.7 or 3 of the annual average daily flow. Yes. Which of the following factor may cause an increase in population? Birth rate, death rate, migration, annexation.
Option D.
Option D, yes. This is very simple. So death rate will cause decrease. Other things can increase your population. So 1, 3, and 4. So again, geometric increase method, I think we have already solved this. So everything is given. Initial population is given. 1.7 is the annual growth rate. And then what is the population after 10 years? So after 10 years is 1 decade. So if you just put the formula population into 1 plus r to the power n. So directly you can get. So correct answer will be, what is the correct answer? Can someone tell me? What is the correct answer? 814,000. Okay, so here instead of lakhs, all the answers are given is in thousands. So you have to convert everything in thousands. Okay, so simple formula, initial population into 1 plus r to the power 1, because 10 years is 1 decade. So your answer will be 813,600,000. So in thousands, it will be 814,000 approximately. Typically, the peak factor of a community does not depend on dry weather flow, population density, site topography, supply hours. The peak factor of a community does not depend on. Why do you think the site topography will not change the peak factor? Suppose somewhere we are calculating in hilly area where there is very cold, and someone somewhere in hot region. Will the peak factor change or not?
Sir,
Unanimous.
this site topography, it is a like slope only, slope based on the topography. It is a condition means upper to down based on if you are taking through gravity, it is a topography. Maybe lower to higher,
I
maybe
think
it is a.
here they mean by site topography is the area or the elevation, maybe, not the
This is
flow which you are saying.
actually, but here it is telling peak factor of community does not depend. It is not dependent on the peak factor. It is only topography, so it is not connected to any peak factor. This is what I mean. Maybe my understanding is wrong, but
No, so actually, what I think is by site topography, they are referring to maybe the kind of place, okay, whether it's a very hilly area or uh, maybe on the in the plains or maybe in the coastal. Okay, so on that, the peak factor will definitely depend because your usage pattern of water will change. Okay, whereas the dry weather flow, that is the minimum flow in the sewer, on that the peak factor will not depend on. Okay, population density, yes. Site topography, yes. Supply hours also, because based on the supply hours, our usage will change. Okay, so peak factor can change. But the dry weather flow or the minimum flow will not change my peak factor. Okay, it does not depend on the minimum flows or the dry weather flow. Okay, so that is the, I think, reference of this question. But I can understand there is a site debatable thing on site topography. So yeah, but as per this question, they are referring to the dry weather flow, because dry weather flow definitely it will not depend on the peak factor. Okay, site topography is debatable, but dry weather flow it will definitely not depend on. Okay. If the average daily consumption of a town is 1,20,000 meter cube, the peak hourly demand would be, assuming peak factor to be 2.7. So what will be my peak hourly demand? Quickly tell the answer. Peak hourly demand.
Sir, option D, 13,500 meter cube per hour.
13,500. Yes, that is the right answer. So nothing, we have to just take the amount. So 1,20,000 meter cube per day, because this is average daily. So we have to divide by 24 hours. So we'll get 5,000 meter cube per hour. Then multiply it with 2.7 for the peak hourly demand. Okay, so that's how you have to do it. So I think mostly today these kind of problems are only there. So one last problem. So this is, you can take it as for your homework. So this is a little lengthy problem. So we won't solve it here now. Just take a screenshot of it. So the question says that the average domestic wastewater flow was estimated to be 300 LPCD for a town with 50,000 seaward population. The sanitary sewer system for the city includes 100 kilometers of 4-inch house sewers, 22 kilometers of 6-inch building sewers, 56 kilometers of 8-inch street laterals, 15 kilometers of 12-inch submains, and 12 kilometers of 18-inch mains. So different sizes of sewer systems are given. Estimate the infiltration flow rate and its percentage to the daily average daily and peak hourly domestic flows if assumed infiltration flow rate is 1250 liters per day per kilometer per inch of the pipe diameter. Okay, and then assume the peaking factor to be 3. So in this question you have to find out what is the percentage, okay, or the ratio of the infiltration flow to the sewage flow, average sewage flow. So discharge of infiltration divided by discharge of sewage, average CH, and the average and the peak hourly domestic flow. So that you have to calculate. And for infiltration, they have given the sewer lengths, different sewer lengths of different pipe size, and how much infiltration flow rate will be there per inch of pipe. So that is also given. Okay, so please calculate it step by step. You can use Excel for this and tell me the value in the next class. Or you can solve this. Uh, no, link anyway the NPTEL team is sharing with you. Okay, and before the class also I will share the class link. So if you have filled, then that is enough. You didn't get the link. Okay. No. There is no link for attendance. Okay, there is no new link. I have just um, Varsha. Anyway, see, yeah, see, for all my classes, this will be the link. Whatever link you have attended now. So every Friday, this is the only link. So every week you won't get a new link for attending the class. Okay. So for you just save this link QCAMYMPSMR. Previous link.
Sir, we have to mark attendance too.
No. There is no marking of attendance. That sheet just for once I have asked you to fill for the email address. Okay, there is no attendance link here.
Okay, thank you, sir.
Okay, you just have to attend the class every Friday 6 to 8 p.m. with the link you are using now. CQAMYMPSMR. Okay, this is the code. You can see in the link. Okay, I will just paste it again in the chat box here. So just open this link every Friday. So not on Tuesday. This is the link not for Tuesday. This is only for the Friday class 6 to 8 p.m. I will take the Friday class. So if you are interested in the class which I am taking every Friday 6 to 8 p.m. Okay. So yeah, coming back to the question. So this question you please solve it in the free time. Okay, you can send me in my email address, which I will share. I think most of you are also having it. So you can send me the answer. Okay, take a picture, or else we will discuss in the next class. Okay, so I don't think we have any more newer problems. So I will share this PPT with you anyway. You can check the session. Okay, thank you so much. Thank you so much. So next class again on 7th August, 6 to 8 p.m. Also, I by mistake I have written Tuesday. It's Friday. So next Friday, 7th. Okay, not Tuesday. I think it has been misprinted. So it is on Friday. And you can contact me on saha19akash@gmail.com. So even if you have some doubts related to previous session or previous classes, you can send me. It's not like you can only ask me the doubts of that particular class or session. No, it's not like that. You can ask me anything related to environmental engineering. If I can help you, I will definitely reply back to you. So this is my email address. Okay. I hope you are enjoying the session. If you have any more suggestions or recommendations from your side, please feel free to tell me. Okay. So that we can improve the sessions. If you have any specific request, please let me know.
Sir, I have a question.
Yes.
Sir, what should be our approach to solving numericals? So this is my first time solving sir numericals about STP, and I found myself really weak around this section. So what should be my approach to solve that?
See, if you are talking about only this course, you follow whatever procedure I am following here. Okay.
Okay, sir.
Okay, that is I think enough for this course. But I would suggest you can use some. Are you from environmental engineering background or environmental science background?
And environmental science.
Environmental science, right? So maybe some standard textbook you can solve the solved problems. Don't go for the unsolved problems. Just see the solved problems. Okay.
Okay, sir.
You try to solve well whatever is given. You please try to solve them. Then also, if you are having some issues in understanding on the solution, you send a mail to me. Then we can discuss.
Sir, like what is the weightage of numericals in the final year exam?
In for this NPTEL course, it will be very high, more than I think 60%, because mostly they will ask numericals only. Okay,
Oh,
maybe
so,
as multiple choice or maybe in numerical method, in numerical answer.
so sir, theoretical portion will be less as compared to numerical.
Yes. Theoretical. That's what I believe, because I am not the one who's setting the problem questions. So every year the question paper will be different. We cannot judge like that, and it is not available online also. Previous year problems and all, so it is not there. So you see
So,
your assignment problems. So the same level of problem will be asked. Don't think that many extra or high level problem will be there. Same level problems will be asked, but definitely 50% will be there, I think.
so to get a certificate, which will be good in numerical section.
Yes.
Okay. Okay, thank you, sir.
Yeah. So as Mr. Rajiv is also saying, so you will have questions directly from assignment and practice session. That will be there, but maybe numericals. But in the short amount of time, you don't have much time to think. So if you are not practicing it before, you won't get time to solve all the problems. So that is the reason you need to practice it before. Okay. And as far as the certificates are concerned, yes, if you get the certificate, you can show in the interviews. Okay. So for working professionals, if you are shifting from one job to another, these certificates will definitely help, because this will be added as a skill and there is a authentic validation for that, that you have completed the course, got this much of mark. So I think definitely it will help you in switching jobs or maybe getting promotions in the present job. Okay. So
Sir,
yeah.
sir, Saurabh this side, sir.
Yes, please tell me.
Uh, Sir, actually, sir, in week two, the problem solving session which held at week two, second week,
Okay.
I have missed that, sir.
No,
So can you
this is
provide
the week 2 lecture.
this one?
Yeah.
Actually, sir, I have received the mail that week one and week two, and today I have received 2 days back. I have received the mail that this one is the week three. This session will be holding for the week
No.
three.
This is, see, there are two things. One is you will get the lectures video link per week. Okay. Every
Okay.
week you will get one link for lecture videos. So every
Okay,
week
sir.
they are uploading some 5 6 lectures per week, and
Okay, sir.
this is another session for only for problem solving. So there are two different kinds of links.
Acha, acha,
Okay.
acha.
So
Okay.
if you are getting the link for week 2 maybe in Wednesday, then on Friday we will have the problem solving session. So like that.
Okay, okay, got it, sir. And this one, it is written that next session will be holding on 7th August. That means
Yes. So
this
see,
will be for week three.
every Friday 6 to 8 p.m. My this session taken by me
Okay,
will
okay,
be
okay,
6
okay.
to 8 and
Okay,
same
okay,
link.
it is okay.
So don't have to change the link also, same link. And
Okay,
I
okay, sir.
hope you have
Thank you.
filled the Google Sheet also. If I have your email ID, you will get a mail from my side also.
Okay, okay, sir.
Okay.
Thank you, thank you, thank you.
Okay.
Okay.
Yeah. BPSC APS WMO exam. No, I'm not aware of this exam. Uh, BPSC, I think Bihar Public Service Commission, right? Okay. So is it some related to engineering, environmental engineering post, or some AE or JE post? What is this? Okay, the syllabus matches. Okay. Yeah, you can definitely go through this. So what I will try to do is, like, I will mostly solve problems in the level of the assignments that you have to do, plus some extra problems which will help you to solve gate level exam or any competitive exam. Okay, because many of you will be giving GATE exams to get into IITs or NITs or maybe some UGC net exams. So my questions will help you in solving those problems also. Okay, so maybe a little bit higher level for some questions, not all questions, some questions. Okay, you can mail me. Okay, so that's all from. Okay, fine. So that's all from my side for today. You can join the class again on next Friday. This is Friday. By mistake, it is written as Tuesday. Okay. So if you have no more doubts, you can leave the session. Thank you so much. Okay. Yeah. Thank you. And I hope you are able to access the link for the PPT and the PDFs, right? If not, from NPTEL side, they might have shared you. So all this PPT and lectures, everything you will get it. So please refer to that. Why there is a glitch in YouTube link? I don't think there is any glitch. No, the moment I upload it, maybe for some time there will be glitch, but if you open it immediately the time I upload, there can be a glitch, but after that I don't think there will be any glitch. Let me check that. Grey water has a very, yeah, it is. No, yeah, my link is working fine. So if you see the link for Akash, okay, that will be working fine. Or else you can go to my channel, Akash Saha NPTEL. Okay, I will just write it up. NPTEL. Okay, so if you see this channel, you will get my lectures. Okay, recorded. Yeah. Okay, that's it. So you can leave the session if you don't have any more queries. Thank you. Thank you so much. Okay, thank you. Yeah, bye. Good night.